On August 30th, 2026, weeks from now, a telescope will leave Earth that will find more alien worlds in its first year than all of humanity has discovered in the entire history of science. 100,000 hidden planets. Worlds that have been invisible to us until this moment. And scientists say some of them could permanently change our answer to the oldest question ever asked. Are we alone? In less than 3 months, NASA launches the Nancy Grace Roman Space Telescope. Its mission to look deeper into our galaxy than any telescope ever has, and find the planets we have been missing for 30 years. The countdown has already begun, and the universe is about to look very different. This is not a future mission. This is not a concept. The telescope is built. The rocket is ready, and the question it is going to answer has been waiting for billions of years. Since 1995, humanity has been discovering planets beyond our solar system. By June 2026, we have confirmed just over 6,300 exoplanets. 6,300 worlds found after 30 years of searching with every instrument we had. That sounds like a lot. It is not. Our Milky Way galaxy contains between 100 billion and 400 billion stars. If even a fraction of them host planets, and evidence strongly suggests most do, then 6,300 is not a census of what exists. It is a handful of sand from an ocean. And the planets we have found carry a deep bias because of how we find them. The dominant method for detecting exoplanets is called the transit method. When a planet crosses in front of its star, from our point of view, it blocks a tiny fraction of the starlight. We detect that dimming and infer the planet's existence. But this only works when the planet's orbit is perfectly aligned with our line of sight. Planets in tilted orbits, planets far from their stars, planets in the cold outer regions of solar systems, they are completely invisible to this technique. The 6,300 worlds we know about represent a deeply skewed sample of what is actually there. The planets we most want to find for the search for life, rocky worlds at moderate distances from their stars, with the right temperatures and the right chemistry, are precisely the ones the transit method misses. They are hiding, and Roman is built specifically to find them. Roman changes planet hunting in two fundamental ways. The first is its field of view. When Hubble photographs the sky, it captures a patch roughly the size of a grain of sand held at arm's length. Roman's wide field instrument captures 100 times more sky in a single image, at identical resolution. Roman will survey more of the cosmos in 5 years than Hubble has in over 3 decades. The second change is more profound. Roman's primary planet-finding technique is not the transit method. It is gravitational microlensing. When a planet passes between us and a distant background star, its gravity bends and briefly brightens that starlight in a very specific way. A gravitational fingerprint that reveals the planet's mass and orbital distance with precision no other method can match. Microlensing finds planets in wide orbits, planets far from their stars, and rogue planets drifting with no star at all. Roman will direct this technique at the galactic center, the most densely starred region of the Milky Way, sweeping repeatedly through a field of hundreds of millions of stars, catching the gravitational fingerprints of worlds that have been invisible to every instrument we have ever built. The expected discovery: more than 100,000 new exoplanets in 5 years. Before we talk about what this telescope is about to find, we need to talk about who it is named after, because her story is as extraordinary as the mission itself. In 1925, Nancy Grace Roman was born in Nashville, Tennessee. As a young girl, she organized a science club for her neighborhood friends and spent evenings mapping the stars. She was told repeatedly by teachers, by professors, by colleagues that women could not be astronomers. She ignored every single one of them. In 1959, just 6 months after NASA was founded, she walked through its doors and changed what was possible. She became NASA's first chief of astronomy, the first woman to hold an executive position at the agency. And she spent the next 20 years doing something that would outlast her by generations. She convinced NASA and then the United States Congress that humanity needed a telescope in space, above Earth's atmosphere, one capable of seeing the universe without interference. That telescope became Hubble. Ed Weiler, Hubble's chief scientist, gave her the title that history kept: the mother of the Hubble Space Telescope. She died in December 2018 at the age of 93, never knowing NASA would name its next great observatory after her. The telescope that carries her name now sits on a launch pad in Kennedy Space Center, Florida, weeks from beginning the mission she spent her life making possible. "100,000 new planets is not just a number. Each world is a data point in the most important question in science: how common are worlds like Earth? And if Earth-like worlds are common, what does that mean for life?" Roman carries something that makes it unique among all telescopes ever launched: a coronagraph instrument, a device that blocks the blinding light of a star so Roman can directly photograph the planets orbiting around it, not infer them from a dip in starlight. See them directly, and in those images, spectroscopy will reveal the chemical makeup of alien atmospheres. Scientists know exactly what they are searching for: oxygen and methane together. On Earth, these two gases react chemically and destroy each other rapidly. If both are present simultaneously in an alien atmosphere, something must be continuously producing them. The only process we know of that does this is biological activity: life. If Roman finds that combination in the atmosphere of a world it directly photographs, the discovery will be the most significant in the history of our species. Roman's coronagraph is described by NASA as a pathfinder, paving the way for the Habitable Worlds Observatory, the next generation mission specifically designed to photograph Earth-like planets and search their atmospheres for signs of life. Roman builds the road, that telescope will walk it. The scale of what Roman will accomplish is difficult to comprehend. every 90 days, it will produce more astronomical data than Hubble has gathered across its entire 35-year lifetime. A team of scientists working continuously could not analyze it fast enough. Much of it will be processed by artificial intelligence, machine learning systems trained to identify planetary signatures across billions of stars simultaneously. Roman is not just a telescope, it is a factory for discovery operating at a scale no human institution has ever attempted. What this means for the search for life is profound. Every new world Roman finds is a new probability, a new chance. 30 years ago, we did not know whether any other star had planets at all. Today, we know most of them do. Roman will tell us how many sit in the right place, the right temperature, the right distance, the right conditions, and that number, when it finally arrives, will either confirm what many scientists already believe, that the universe is full of possibility, or force us to face the most uncomfortable question we have ever asked ourselves: why is Earth the only one? And beyond planets, over its 5-year mission, Roman will measure light from 1 billion galaxies, produce 20,000 terabytes of scientific data, and probe the 2 deepest unsolved mysteries in physics: dark matter and dark energy, the invisible forces that together make up 95% of everything that exists. On August 30th, 2026, a SpaceX Falcon Heavy rocket will carry the telescope named for the mother of Hubble into space. The Roman Space Telescope will spend the next 5 years doing something that has never been done in the history of our species: photographing the galaxy wide enough to find 100,000 hidden worlds and studying them closely enough to ask whether any of them are alive. The answer will arrive in our lifetime. It may arrive sooner than anyone expects. Subscribe now and we will bring you every discovery the moment it happens. The universe has been hiding something for billions of years. Roman is about to find it.